Okay, we're getting back from break here, and we just left off talking about the buffer that's used in all of the generic Fanuc 4-axis MT lathe posts. So these are the normal mill turn lathe posts that work with the regular lathe product. And we've been examining how that buffer works. If I look, this is generic Fanuc 4X MT lathe post. So this is MPL fan. I'm going to close that one out. And let's go open shared MCAM X7 lathe posts generic Fanuc 4X MT lathe. If I go look for FBuff, so I'll do a search. Oh, let's make sure I'm broadcasting. Everybody can hear me right. Can I get a quick show of hands? Craig, thank you. Bill, okay, cool. I just wanted to, I'll go ahead and put everybody's hands down. Thanks, guys. I just wanted to make sure broadcast was happening and we're looking good. Well, hold on one sec, everybody. Hold on one sec. Okay. My wife had to come and ask me a question. All right. If I search for FBuff, oh, you know what? Hold on a second, guys. I know what's going on. I had plugged in an external USB hard drive, and I unplugged my extra keyboard to do that. So there we go. So now Control F, and we're looking for FBUF. What I'm going to do is turn on the keep flag for this buffer. So in this particular version, you notice we have 29 parameters there. And what I'm going to do is make sure that up above, so I have to be above the buffer definition itself. I'm going to come up here to buffer 1, and I'm going to set the name. sbuff name something, right? If I just type in sbuff and I do control spacebar on my keyboard, I'll get a list of all of the predefined variable and post block names that exist in MP. So again, this control and then holding down control and pressing the spacebar is really useful. You don't even have to type anything. If I can't remember what a variable name is and I just do control spacebar, that will open my list with basically every predefined keyword that exists in MP. Okay, so if you can't remember what something's called, or you want to make sure that you're not stepping on an already existing variable without knowing it, this would let you do that. So I want s buff name 1. I'm going to start it in the first column, and I'll initialize it, and I have to use a fully qualified path. So in this case, I'm using C drive. You can use a network file if you guys want to save this data to the network by using a server name, right? And I believe it's something like this, and then like a %sign in the name of the path. You'd have to ask it's pretty much standard Windows convention for specifying the server. So find out from your IT guy, or if you can always do that. So C:\/ for local. I want temp. I have a temp folder that I created, and we're going to call this Gen fan 4x MT lathe, and we'll call that buffer 1. And we can specify any extension we want for it. But keep in mind it only writes out ASCII text. So if we say .doc, that's fine, and Word will recognize that and open it up, but it's just plain, like, basically unformatted text. I mean, you get spacing and you get carriage return and line feed, and that's about it. The standard notation is to do TX1 for the buffer 1, TX2 for buffer 2, TX3 for buffer 3, TX9 for buffer 9, all the way. And then for buffer 10, it would be TX0. So that's the standard kind of convention that we use. I'll do TX1, save it like that. By saving an initialized name up above the buffer definition, we can direct MP where we want to write this data to when we choose to use the keep flag to keep the buffer when it's all done. Okay, so now what I'll do is take a file that has lots of existing operations and we'll post it. Not sure what it tripped out on as far as valid cut type. It might be the Pogo ops maybe aren't configured. Yeah, it's probably something like the Pogo ops. Could be something in the buffer though. So we'll have to see. So I'll close that out. And if we go look, see temp genfan 4xmt lathe buffer. So this is what the output from that file looks like. It basically has every tool change event. Okay, 1001 is always the start of file. Start of file. 1000 is a null tool change. 1002s are actual tool changes. 1000s, null tool changes. 1002 is an actual tool change. Here's some more null, then some actual, then a null, then so this file now has a list of all the operations and whatever parameters we decided to capture at that time. Okay, so this particular example, in my mind, is one of the more extreme examples of using a buffer file. Now, what it gives us the ability to do, though, we've written all this data. So if we got to the end, we could do we could read the 0 record, and we could determine how many lines are in this thing, right? We've got 43 lines. And we could, as we read the data, we can check the value of the first piece of data that's written to determine where we're at. Are we at an actual tool change? Are we at a null tool change? Is it the end of the file, right? Like, where are we? What are we doing? And this file, because we know the start and the end, we have unlimited access to the data that's in this file. How do we get access to this data? What is the key to being able to choose where we're at? Who's got an idea? That's right. It's the read counter. It is well, and to a more another way of saying that, we have a read counter and a write counter variable that we have control over. We can set that value, and we can tell MP which record from the list to go grab. And like we saw with our sorting routine, let me go open up that file. It's actually MP fan, so we want shared MKMX7 mil posts MP fan. And if we go look at our sort, here's our sorting routine. So what we're doing here is we're controlling that read counter. We're setting it to a specific value, and then we're reading an array of variables. So this sets work offset 2, it sets like POFS2, it sets TOX2, TOY2, and TOZ2. This one line of code sets 5 variables. And it starts with whatever this value is. As soon as this code is executed, RC2 is incremented automatically by 1. This happens in the background. Then we use a different array here. So we say work offset n equals, rbuff2 RC2. We could potentially also create some logic in here that says, I have a set of previous values because I want to know what happened at the last tool change. Or you know what? I don't just care about next tool change. I want to know what happens at the next tool change and another tool change ahead, right? Like, is it a null? Is it this? Is it that? I want to be able to look ahead and see, where the next drill op is. Okay, so sometimes we have issues like 5-axis machines, and you are doing 5-axis cutting with an end mill. So you turn on tool center point control, or you turn on some mode that's special for that type of operation, and you've got this tool, and you're going to do 3 operations, but there's some depth cuts and some multi-passes. So you've actually got 6 different tool change events. And if we go and look at, the buffer text, you can go and look and scan ahead and find out when the next 1002 is, right? Like, you could write logic to basically loop through the buffer and say, okay, from where I'm at now, how many operations do we have to get to until we get to the 1002? And we could leave a mode on until we had to cancel it. I mean, that's just an example of how to think about this, because by having control over how we read and write the data, which is right here, that specific parameter gives us a lot of control. And being able to do this, while loop inside a while loop, okay, being able to write this data structure gives us a lot of control over how we can parse this data and sort it. We can't do this with NCI. Okay, there is no sorting mechanism that exists for that. So things like tool table, okay, when we write out the tool table from Mastercam, let me go turn it on. Tool info. What do I want? Oh, I don't have it at the header in this particular post. All right. Here's what we'll do. Yeah, it is in the mill. This tool table here is output based on a mechanism that is in MP. If we go look at MP fan, which is where we did that work, I mean, the tool table already existed in there, but we did the G10 lines. If we go look at MP fan, oh, I already had it open, that's okay. And we look at PWRTT. This line right here decides when we write data to the tool table. This is how it works. It says if tool info is greater than 1 and $T$ is greater than 0 and G code is not 1003. Okay, so first of all, we have to enable it. We have to turn this switch on in the post. And it won't write an entry for the end of file. We know that, okay? But what is this? If tool $ is greater than 0, you're thinking to yourself, when was the last time you guys used a negative tool number? Anybody? No, you don't. Everybody uses positive tool numbers, right? You're going to use tool 1, you're going to use tool 200, you're going to use tool 5. But what happens is MP in the background keeps track of your tool numbers. The first time a tool number is encountered in the NCI, a unique tool number, the first time that tool number is encountered, MP creates that entry and it signs tool $ positive. So let's say the first time is tool 5. So T $, first time, let's do this, let's just write this out like a logic thought. Okay, so the first time T5 is encountered, T $ equals 5.0. It's actually held as a real number value. It's not held as an integer. So just to let you guys know that. Any time after that, any other occurrence of T5, T $ now equals minus 5.0. MP does this automatically for you so that you don't get a tool table list that has multiple repeat entries. Okay, if we go back in our example here, I've got a bunch of operations, but I ended up just taking 6 operations and making copies of them. So let's do that again. Let's do this. Let's copy those. Before that, let's take these 2, copy them after that, and then let's take the whole thing and copy it after. So now we've got a bunch of copies of the same operations. If I go back into our post here, and I simply remove this condition. Let's take out tool $ greater than 0. Let's save that. Let's go bookmarks. Okay. All right. So now I remove that condition. I'm going to go back into Mastercam and post this. Here's the old tool list, right? Here's my new tool list. Check out my tool numbers. See the negative ones? Okay? So that is the mechanism in MP that filters out duplicate entries. But what you'll see is that there's no option for sorting. Okay, so we have this data, but we don't have anything that sorts it. Okay, so something to think about. This is one of the things, getting rid of that condition and actually modifying it based on some other things, is one of the things that I usually do for these tool lists. Because what'll happen is a lot of times people want an entry in their tool list if the stock to leave changes, or maybe they have a different H number. Sure. Bill's got a question. What about for a VTL where you have an ID and an OD tool and a RAM and use one tool number with two offsets? Sure. I mean, what I'm describing right here, Bill, is specific to tool list creation. Now, as far as you want to show that in the tool list and also be able to drive it in Mastercam as well. So we probably have to do something else, but with respect to controlling the output. But this is certainly something where a buffer could be used to not only capture the data, but sort it. Because again, we don't really have any sorting that is built into the tool list mechanism itself by default, right? So, and again, let me just do this real quick. If I undo that and save it, and we just repost, just to show you no tricks up the sleeve, it now filters out, so only the first occurrence of each of those tool numbers actually gets reported. All right. At this point, we've pretty much covered all of the main sections that I wanted to cover related to string buffers and real number buffers. This is that's kind of the information that's given to us in the MP documentation. So now at this point, we're going to go ahead and open it up a little bit and discuss kind of what we've done and what else would be useful. Okay, so we could certainly do some work to create a sorted list of tool numbers. We could do some more work to modify the tool data that's being output. All right, we have some basic options right here to set all those values to 0. But what if we wanted to include some data with that tool, right? What if we didn't just want to set R0? What if we wanted to set something else? Now, we can do a lot of stuff. We can add a lot of stuff, but I want to know what's useful to all of you. I mean, you guys are the ones who are going to drive the rest of the class and the 3 office hour sessions that we're doing this next coming up week. So, the office hours that we've done so far has been mostly with myself and Craig. DJ did pop in for a little bit. And what we have been doing is taking a Mastercam post and adding code to output a centerline file for machine simulation. So the idea behind that being, you can have your post processor output a custom move list for machine simulation that will actually show things like machine retracts and approaches where those are, you know, a G91, G28Z0, where those aren't shown normally in machine simulation, because normally machine simulation doesn't use post processor output. Normally machine simulation uses generic NCI input. This ability to output machine simulation code gives you kind of an intermediate place between stock simulation in Mastercam and a program like Vericut. It doesn't by any means get you all the way to the Vericut status. I mean, Vericut reads the actual G code, so you can simulate just about anything. But what this will do is let you see anything that is a positional move that is output by your post processor. It will let you see that in the machine simulation. So that's what we've been working on for the last couple of office hours. The office hours is really the time for you guys to get the most value out of this class, right? Because a question like Bill's asking, what about for a VTL where you have an ID and an OD tool and a RAM and use one tool number with 2 offsets? That question is a perfect example of what I need to be able to help you guys go to the next level with this stuff. If there's more stuff you want to do with G10s, right? If it's, you want to do some L10 values or some L13 or whatever it is, if there's more data that you want to be able to set, it's easy to capture with a buffer file. Okay, and we've already got the sorting routine in there that sorts based off of tool number. So including additional data or including, additional lines of output, that's not a problem. That's what we're here for. But I need some feedback from everybody in order to be able to do that. So I think, there we go. So here's a question. The R value should be the overall tool length in Mastercam. Can you show us how to pull that info? Sure. Yeah, I'd be happy to. Bill, I'm going to need some more info from you about what you want to do with your VTL. And maybe if you can come up with a sample zip-to-go file for me. If you can send me a sample zip-to-go file, I'd be happy to work through the entire example during an office hours. And we can talk about it, because we want to make sure all the things line up, right? Like, you want to be able to do the tool table that shows the information correctly, but then we also need the values to come out correctly when you're driving the tool paths themselves, right? So, like I said, if you can come up with an example for me and send me some samples, then we can work through that as an exercise and see where it makes sense to incorporate a buffer file into the process. Okay? So let's look at first Craig's question. We're going to output the R value for the overall tool length. And I think, correct me if I'm wrong, but don't we want to do this at the end of the program to set them back to 0? I thought I saw a note in the little section about that, but maybe I'm wrong. So, anyway, well, let's look at outputting the correct R values, first of all. Oh, okay, good. So Bill was asking questions related to what you're talking about for a tool list and having duplicate tool numbers, but with different offsets. So, yeah, let's look at that. We'll have to again, if you can send me an example to start from rather than having to set one up from scratch, I'm sure we could go through it and get it fixed pretty quick. So let's look at Craig's thing, because we can do that right now. The R value should output the overall tool length in Mastercam. Could you show us how to pull that info? So what we're looking to grab, actually let's just do it this way. Tool Manager. What we're grabbing here is this overall tool length parameter. So this is going to be coming from basically the bottom of the holder. So this is the the overall, or the out of holder height, not just the actual length of the tool. And that's the important thing to note here. If we're setting a tool length value programmatically from Mastercam, this value would really need to be equal to whatever your tool length compensation value is. So say that this is sticking out of the holder 2.25 inches, but your tool length compensation value that would go on your input screen is like this, 5.5632, okay? We would need to put that value here, and we would want to go somewhere here, and we would want to adopt a practice of doing something like this. Now 0.031, end mill, and something like this. Actually, 031 dash end mill flat, something like 0.0625 dash FL for the flute, and then 2.25 out of holder, overall length, OAL, whatever you guys want to use for your nomenclature. I would end up putting the amount that it sticks out either off of the tool list. Sometimes you can use act reports to just generate it. But again, this is where we want to grab this value. So you have to be careful when you guys define this. All right. So when you're defining your R value and you're taking it from this overall length, we can take the value from anywhere, right? Since we've got a post, we've got access to pretty much any parameter. We could take it, we could literally put it in the chuck entry thing right here, and we could use a string function to extract a numeric value from the string. Okay, there's a lot of different ways that we can consider going about this. So keep that in mind as you start to invent these processes, you want to think about the overall impact you're going to have. This, including the value here for the overall length, is going to impact how your tools display. Okay, so this really, what you're going to want to be taking is the length of the tool plus the length of the holder. I believe starting in X8, we're finally going to get access to those parameters. We have a little bit, actually I shouldn't say it's a little bit. We have a lot of an issue right now because we have multiple ways of defining holders. We've got the old style where you actually had some holder info that was just like a basic diameter and a basic length, and that was it. And we've got the new way of doing the holders. And so far, until we get to X8, there's no way to get some of that data, unfortunately. So you're going to have to come up with some methodology that makes sense until that data is available. If we go in, for example, I'll just do create a rectangle, turn on surface creation, toolpaths, surface high speed, and we're going to do raster. If we select one of these tools, this particular one's a 1/2-inch diameter tool. It's got a 1-inch overall length. If we then go into the holder, here's just the default holder. And again, the problem is until we get to X8, we have some limitations, I guess you could say. So here I've got a holder. I like this holder, right? And if I actually go and look at my tool's not really 1 inch long, right? I go and I buy this from the catalog, and I do like I normally do, and I say, all right, my 1/2-inch tool is 3 inches long. Okay, so there's my 1/2-inch tool. Great. Now I'm going to go chuck it up. Okay, so 3-inch tool, 1/2-inch diameter. We're going to update that tool. I'm not going to worry about the holder for a minute. Going to regenerate everything that needs regenerating. Now, if I go back and I look at this, still a 3-inch tool, everything's hunky-dory, right? Now I go into the holder, and I say, oh, crap, here's my holder. Really, I'm going to chuck this bad boy up. So I really only want this thing sticking out like 1.25 inches. Okay, now I say, okay, great. I'm going to update tool in all operations that use this tool. Everything looks sweet, right? Say, okay. Gonna regenerate it. Everything looks good. I go in and I say I want to back plot that, and I'm gonna turn on my holder, and I'm like, awesome, it's sticking out the right amount, everything looks pretty good. Okay, but now I go back in and I check my tool, and that's what it did to me. Everybody see what happened? By using that tool projection on the holder page, Mastercam actually adjusts the actual length of your tool in the tool definition. So there's some work that you guys have to do until we get to X8 for dealing with this kind of stuff. In this case, what I'd really recommend you guys do, create your tools, create your holders, build your assemblies if you can beforehand. I know you can't always do that, but once you've gotten this stuff, you're going to need to enter this data somewhere manually, because you really can't get the data itself. Part of the problem is that this 2.38 doesn't really exist. These are individual segments that actually all get added together to give you this overall distance. And they're actually going to give us all of these data. They're going to give us the overall length, the overall width of the holder at the highest point. They're going to give us the height of the holder. They're going to give us the amount of projection and stick out, and they're going to give us the overall length of the tool. So we'll have all the data that we eventually need. We just don't yet. So, we've got to enter it somewhere. What I would do is say that we want to do something like this. I'm going to take a picture of my tool. I'm going to go back to the tool definition itself, and we're going to go to the parameters. And I typically use the manufacturer's tool code for the actual manufacturer's tool code. And I'll typically have some kind of, description here. 0.5, dash EM, maybe it's 5 flute. Something like that, right? And then this is going to come from Haneda. But in the chuck, we can do kind of whatever we want there, right? So I would do something like this. We've got overall length. We've got holder length. And we've got projection length. Okay, or out of holder, or whatever you want to call it. So the first thing we're going to go with here is OAL space, and our overall length is going to be 3.63. And maybe it's 6.6345. Okay, because we measured it on our presetter. Then I'm going to do a space. And then I'm going to do H You know what? I'll just do holder. Overall length. We've got our holder, and our holder is going to be 2.385. Okay, 2.385, and our projection, what are we going to call that? We're going to call that maybe, it's not really length below the shoulder. We've already got holder. So how about PROJ? That's the distance of the projection. Okay, so our projection is going to be 1.25, right? Okay. So we've put in this custom string that's in the chuck parameters. Make sure I regen that. And actually, we should be able to see it in the contour toolpath up above here. And I'm just going to change the NC file name here just to test one so that this is its own separate program. And if I look at that tool, I've got that data there. So if we post out and we look at the NCI, now there is, sure that's just the regular. I know there's some options sometimes that you can turn on and off on what gets output. So I just want to make sure that's included. You know what it is? I think they're actually written as parameters, but they're not available in the NCI, so we have to do a parameter extraction routine. So we're going to go back into the post processor for MPFan, and let's go down to the parameters. We're going to go to the X7 NCI and parameter reference. We're going to go down at tool information. $20,002 and $20,003 contain the manufacturer's tool code and the chuck name. So it's going to come out as a string. So for 20,003, I'm just going to say if param code $, equals 20,003. How about we say S S chuck. I'm going to call this str string. How about T chuck? Because it's the tool chuck parameter. Equals S parameter $. This one is easy to capture. I don't have to use a function because I'm not trying to automatically convert a numeric value or an array or read an array of numeric values from a string parameter. I'm just trying to capture the entire string. So I just say str underscore tchuck equals S parameter. We want to capture capture the chuck string from the tool definition. I'm going to copy my nice little variable here for str chuck, and we'll do a find, and I'm going to just search for FMT so we get up to the top here. Okay, these are all the numeric values and miscellaneous string definitions. This is probably fine. So we're going to create this one, str tchuck, And we're going to say this is a string to capture the chuck string from tool definition. Okay, makes sense? String to chuck. Now, I've already got some temporary strings defined. So I think I'm going to do this. Just going to create a couple of extra temporary strings because I get the feeling that I'm going to need them, and I'll show you guys why. Now, along with this, we're going to need some numeric values. We're going to need tool overall length, and that's going to be this is going to be the OAL length for G10. We're going to need holder, maybe just call it holder length. And we're going to need, what else do we have there? Projection. Okay, tool projection length. Now, we need to check this str_tchuck line. We need to search that line for OAL, holder, and PROJ. So what we're going to do is create some strings for that. Jury's out on whether I'll actually need stemp1 or not, but we'll see about those. So what I want is SOAL I want S holder, and I want S PROJ. Okay, so those are the strings that I'm going to search for. Now, I'm reading that string each time a new tool is read. So I'm going to save that. Now, let's see. Pretty sure the parameters are read before every tool change, and this is going to go through the tool change post block anyway. Okay, so what we're going to search for is PWRTT. Okay, and PWRTT, this is where we're doing the write buffer. Let's get rid of that extra stuff we don't need. Okay, so tool offset write buffer, that's where we're holding the tool offset. And we need to modify this to hold a value. Right now we're loading the tool offset number. So I'm going to set a bookmark there. We're going to search for offset 3 because I want to find the definition. And This is going to give us our tool number, and we're going to need our tool length, right? So we're going to need FMT R. How do we want that number to come out? We want it to be 4-place decimal if it's inch, 3-place decimal for metric, right? So if that's true, we want to make it a 2. So that's the offset value, which is really the tool. This is going to be OAL LEN, overall length for buffer number 3. Buffer 3 OAL value. Okay, so that's what we're going to be outputting is this R. The offset N reads the next offset value. But keep in mind, whenever we read and write, we do so with however many variables are in the buffer definition at a time. So we also need a next thing. So we need OAL LEN N for next. Okay, and that's also going to be 0 because we're reading and writing 2 values at a time. And this is next buffer variable. Okay, and what we're going to do is modify this so that the buffer definition holds 2 values instead of just 1. So buffer number 3, we're going to keep it, and we're not going to initialize it, and we're saving 2 values every time we write. We've got a list of 2 values here that are actually going to get output, and we've got a list of 2 values here that hold the next variable definitions. Okay, so what we're going to search for is offset 3. This is where the output occurs. Okay, so if sort U10, we're going to sort it RC3 equals 1. We get the size of the buffer. So we start at 1, we get the size of the buffer, and we count up from 1 to the size. Now, offset 3 equals read buff 3 RC3. This now loads 2 values. Why? Because we told it the buffer definition has 2 values in it. Now we're going to get PBLD and $, SG absync, G10, L12, and instead of R0, we're going to force out the other value, and that's going to be OALLEN3. Okay? So that's going to give us our output. Now we need to make sure we sort correctly. And in fact, this sorting occurs just based off of offset N and offset 3. So as long as we're only sorting by tool number, we don't care about any of the other values, we don't have to change a thing. Okay? And when we write to the buffer, this is where we have to change the R value that we write. Okay? We're only looping through and checking the tool offset number. Okay, so that's if the tool offset number's been repeated, we're gonna flag it. We're not gonna do this. Now the only other thing we need to change here is to say OAL LEN3 equals, and this is where it's gonna get a little tricky. I'm going to save where we're at. We're going to go back to the documentation portfolio. And we're going to go look at scan. This is a string function. It determines if one string is a substring of a second string, and if the substring is found, scans for a number starting immediately after the location where the substring was matched. The second argument is compared to the first argument to determine if the second argument is a substring of the first. So the return value is the number scanned from the first argument, or 9999 if no substring or no number is found. The helper variables return the index characters. So what we're going to do here is this. Let's shrink this down a little bit. So overall length 3 equals scan, and we're going to scan the string that holds that tool chuck. We're going to scan str underscore tchuck for which string? We want SOAL, I'm pretty sure. So if we go look at our bookmarks, we're going to search for OAL in that string. And we're going to load that. I guess we already had the offset, the OAL offset. You know what we should do, actually? We should probably not try to combine these functions. So let's go and look at this. Here's what we're going to do. We're going to say tool overall length equals scan strchuck for SOAL. At that point, that should return whatever the number is after the OAL. It should put that number in tool OAL right here. And then what I'm going to say is OAL len 3 equals tool OAL. So now we're going to properly set that value based off of the scan work we did up here. Okay, so that's how we're capturing that value. Let's see it in action. So again, I've got OAL, 3.6345, and if I post that out, So I wonder if it didn't get to that. I wonder if that data's not available there yet. So here's what we can help do to test this out. This is all scanned in during the NCI pre-read, which I think is part of the problem here. So this strtchuck may not be available. What we can do is do this. Okay, so first let's see if strtchuck has any data. Yep. So that string might not be accessible from where that is at. We may be able to include the read parameters keyword in PWRTT before we write the tool offset write buffer, because normally that we should be reading these values, but you can actually force it to read them. So let me see if doing that helps at all. Nope. What do we get for errors? Requested parameter data object was not created. So it may not be possible to get that data at that time. We're gonna have to find out how we can get around that. So I'm gonna first of all get out of that read parameters, and let's go look at our bookmarks. Here, let's just make sure this is working. Yeah. So the mprint statement is working just fine. And still want to try and capture this guy. Yeah, I'm just trying to think if there's any other way that we can go about capturing this. Well, the problem is, Craig, if we're trying to read it after the tool change, we can't assemble it all into a list and stick it up at the top of the post, which is what we're after. So as far as getting this, built into a list and sticking it out at the top of the program, we're gonna have to think about that. All right, just over an hour in. We're still going to work on this little issue. That's okay. I'm sure we'll get it figured out. But are there any questions up until now? Cool. All right. We're going to go ahead and take our last break for the day and come back, and we'll have, about 45 minutes or so to go for the last part of class here. Actually, maybe a half hour. So it's almost 4:45. Let's go ahead and break until 4:55. Okay.